Hi gang, let's talk about a project. Sorting and looping is what we're going to deal with in here. And in this project, I've laid out something similar to what I've got you doing, but I want to go over the concepts because not everything we need is in the exercises anymore. They've changed some of the things. So I'm going to walk through this and we'll get a good lay of the land, get a good understanding of why we're doing things a certain way, and we'll go from there. So I've created a program that asks the user for a list of dog breeds. That could be anything, but we see here on line 12, please enter dog breeds. Enter X when done. Now, the X, does it have to be an uppercase X? Well, I'm not doing data validation in this exercise. So we're going to work under the assumption that the user is providing everything the exact way that we've asked them to. So with that said, we've got a couple things up here that we've dealt with in the past using system, and then a bit more explicit using static system.console. Static meaning we only want one console running at any given time. And then we've got our class. Since I'm doing this in REPL or Replit, it requires me to have this class named program. Now, within my class, I have a main, and I'm not doing any other methods with this. It's just the main. And the main that I've got has the traditional declarations. And along with that, I've got an input string I've declared. So I'm going to acquire input from the user. I'm going to then check to see if it is in fact an X or not. And if it is, I'll end what I'm doing. If it's not, then I'll take that and I'll add it onto my array. Now, I've declared this array, and this array is an array of strings. So I guess conceptually it's a three-dimensional array or two-dimensional array, because one dimension is the height of this list that we're creating, and the other is the characters within it. But we'll just treat it as it's a one-dimensional array of strings, and we have not initialized any values in it yet. We have reserved the space, and we've given a name to that space. We've called it breeds array. And matter of fact, let me change this. I want that a lowercase b so I'm actually doing things correctly. So there we go. One more. Okay, so I've declared this array called breeds array. It has no size to it. There are no values being stored at this point. I've also got an integer I'm declaring, give it a name of I. It's initialized to 0, and that's going to be a counter. So I'm going to start counting at 0. It's initialized at 0. Let's go play with this real quick. I'm going to show you something. So on this array, I've declared it. At this point, how long is breeds array? It's the length. Let's go run this and see how long that array is before I get to this first prompt. So it's going to go and check the length attribute of that string array. Currently, that array has a length of 0, meaning there are no values stored in there. Okay, that works. I'm going to go ahead and comment that back out. It's a test to see what's taking place there. I'll stop the code from running. I prompted the user for the input. I haven't received it or accepted it yet. But then I'm going to come down and I'm going to create a while loop. Now there's two types of loops that we use quite commonly. One, I know how many times I'm going to go through this repetition, and the other, I do not. So the one that I do know, that's traditionally a for loop. The one I do not know would traditionally be a while loop. Now we create the while. I don't know how many breeds that the user is going to input. So I could say while what they give me, that input string, is not X, not equivalent to that character X. We're going to keep doing this. That's one way. Another way is what I've done here, while true. While true, true doesn't change. It stays true all along. So I just created an infinite loop. It will keep doing what I'm telling it to do until such time as I break out of it. Now I'll joke sometimes and say, well, here's an analogy of how these loops work. I'll compare a while loop to a relationship. While both parties are faithful and true and have not strayed, if you will, we will continue this relationship. If at some point that condition becomes false, somebody's cheating, what happens? We break up. So that's a loop, if you will, but in the context of something that we've seen or heard over the years. So I get into this loop. I need a break to get out. I prompted the user for something. The next thing I need to do is receive that value from them. So the read line is listening to the console and takes whatever it's heard or whatever's been typed in until such time as somebody hits the enter key, and then we store everything up to the enter keystroke in a variable that's input string. So that's the string that somebody's entered. I'll then compare that and say if input string is not equivalent to uppercase X. Notice how I said that. Not equivalent to. I didn't say not equal to. I said not equivalent to. Equivalent meaning they're the same. Equals is an assignment operator. Okay. So we've got to be clear on how we're wording this to get the right understanding of it. I'm just comparing two things. I'm not taking that value and putting it or assigning it to that variable. It's a comparison operator. So we compare them. If they are not equivalent, we come down to this block of code. Else, what do? We break. Meaning if they are the same, break. So what are we doing in this little block of code? So on line 20, I've got a built-in class. That's the array class. I created an instance of it up here. And that array class has in it a resize method. And if I pass that resize method, the first thing I'll reference what's in breed's array, whatever's in there. And once I've referenced it, let's talk about the breeds_array.length. How long is it? Plus 1. So I'm saying go get the length of breeds_array and add 1 to it. So right now the length is 0. And we're saying add 1 to it. So in this statement, we're saying the built-in array class has a resize method. What do we want to resize? We want to resize that breeds_array and make it now as long as it used to be, but plus 1. Or 1 is how long it'll be. So it didn't have a position. This line right here opened a space up for me to put something in that array. Here's a test to see how long that array is at this point. So right there we knew in line 12 how long it was. Here we'll see how long it is after it's been resized. And I'll say the length is now. Boom. And then after I've done that, I've made a place to store something in that array. I take what the user's given me and I put it in breeds_array I. I has a value of 0 the first time through, and then after it increases by 1, I++. Okay, let's run this and see how it acts up to this point. That's saying I've got a problem on line 21 with, it's not input num, it's breeds array. I'll run it again. Length is 0. Now we're at this point in the code. We've come past it. We're in the loop, and it's now listening right here. It's listening for me to hit the enter key. Let's say pug. The length is now 1. So I entered pug. Input string was not equivalent to X. We got in here. We increased the length of the array by 1. So take what it was, add 1 to it, resize it. Then we have that output statement. The length is now 1. We took what was there, that pug that was input, and we assigned that value to that first position in the array. Let's come back. See how it just gets longer each time we go through. And then if I hit X, we proceed. Okay. So with that said, we've got an understanding what's taking place here. This will keep doing this until such time as it sees that value. And if it does say what they've input is equivalent to X, oh, that's the else. We break out of the loop. Indentation's a big deal. So where this is has to align up with that if. Now, once we come out of this while loop, we've broken, this break right here takes us out of the while loop. Let me shorten this up a little bit. add some space there. Here's another built-in. Instead of array.resize, we've got array.sort. So there's a function. I can change how these arrays work. Say array.sort. What do I want to sort? Breeds array. It's going to sort it out ascending. So it took what was there and then sorted it all out for you. So now whatever's in there is sorted, regardless of what order it was entered. And then the next statement that we have is a header. The breeds are followed by another loop. Now this is a for loop. This for loop starts with, I declare an integer c. That's going to be my counter or my incrementer to get through it. C is going to start at 0. And I don't want to go through this cycle any more times than would put me past the end of the array. So let's think about the array as like a train with train cars. And we assembled the train up here. We started out with car number 0, car number 1, car number 2, car number 3. Since we start counting at 0, if I run through this, and let's go ahead and run the code and test it and see how many times it goes through these different things. So it's going to ask me for the dog breeds. We do pug, Doberman, Dane, and we see that the length is progressing. The length is now 3. We have 3 items in there. In position 0 is pug, position 1 is Doberman, and position 2 is Dane. So I want to print out each one of these, position 0, 1, and 2. So I want to go through this for loop, start out at 0, and I want to keep going until, or as long as, that counter, that incrementer, is less than the length. The length is 3. So I'm going to go 0, 1, 2. I'm still less than 3. That's as far as I can go on this incrementer because it's going to each time increase it by 1. So the first time, right line, breeds array 0. Come through it again. Right line, breeds array 1. Come through it again. Right line, breeds array 2. It'll increment, and then it's going to say, wait a minute, breeds array length is not greater than C. We have to stop. Okay. So if I came back and I comment out those little statements I put in to check to see how long the array was at any given point, then we can go run this, and it should be a little cleaner. The system's been a little laggy, taking time to execute. And I'll go ahead and stretch it out a little bit. Now I'm going to enter that big X. That big X is going to be what ends it, and then it took that list, or I should say that array, of names and sorted it for me right there on line 30. So they are in alphabetical order. One of the things that you may notice over time, a word that starts with an uppercase is valued different than a word that starts with a lowercase. So if I run this, I'm going to start with a big D, Great Dane, and a little d, dog. Now let's look and see what it did. DA, DO, it sorted these in a way that it's looking at that first letter, not so much what it sees after. Okay. So the uppercase has a smaller value than the lowercase. Uppercase, PU, lowercase, PI. We would think maybe this, if we were looking at the second character, well, that would be the other way around. But it's the fact that the uppercase has a smaller value. So we may, at a certain point, need to capitalize that first letter and make sure that regardless of what somebody typed in, we treat them all with the same capitalization. That's something we can do later on. There's a number of things that come into play when we're dealing with data validation and making sure that the data is consistent on what's being input. And we'll deal with a lot of that in chapter 11 when we deal with the exceptions and things not being as we expect. Okay? So if we take this concept and we think about the sorting and whatnot, when it comes to the numbers, we want the user to enter numbers. Conceptually, it's not far from what we're doing here. But you're just going to have to deal with different data types and how things are worded, if you will. Okay?